Hi everyone, I'm Akanksha and I'll be presenting our work Improving Robustness of Semantic Segmentation to Motion Blur using Class-Centric Augmentation. Our work targets the task of semantic segmentation and seeks to address the performance drop that occurs when models trained on clean images encounter real motion blurred images. We propose an augmentation strategy that is class-centric and uses the segmentation annotation maps to synthesize motion blur during training, leading to increased generalizability to real blur images without a loss in performance for clean images. So, improved results are obtained using our approach. Semantic segmentation as a task involves assigning one of n possible objects or stuff classes to each pixel of an image. The fine-grained nature of the task makes it a challenging problem. A lot of research has focused on improving segmentation performance on clean images. But not all images captured in the wild are clean and degradation-free. In particular, motion blur is a commonly encountered degradation ever since mobile phone cameras have become ubiquitous. Segmentation models trained on clean images struggle to perform well on blurred images. As you can see from the figure here, blur severity increases from L1 to L3, and there is a steady drop in segmentation performance from L1 to L3 as well. Few works have actually tried to investigate and attempt to alleviate this issue. One work studied the impact of blur on performance of a series of vision tasks and reported a significant drop in performance for segmentation. Other works have attempted to benchmark the robustness of semantic segmentation to a set of common perturbations and corruptions, including motion blur, and have attempted to improve it. Unlike most other degradations, motion blur is more complex and diverse. The range of different motions from camera shake to dynamic objects that can cause it are the main reason for making it more challenging. Additionally, due to the omnipresence of handheld cameras, it is very commonly encountered. So we believe there is a need to develop an approach to improve the robustness of semantic segmentation to generate motion blur. Our approach involves generating synthetic motion blurred images comprising the entire spectrum from camera shake blur to dynamic scene blur to augment the clean training data in order to improve robustness to generate motion blur. Now, how do we generate synthetic motion blurred images? While GANs are known to be more realistic for the synthesis of motion, any kind of blur, but they don't offer any control or interpretability. Motion blur kernels, on the other hand, can be used along with ground truth segmentation maps to generate synthetic dynamic scene motion blur. We ensure that a diverse kinds of blur kernels are generated by varying the non-linearity of camera trajectory and the exposure time of the camera. Some example blur kernels that we use are shown here. As we move from top to bottom, the exposure time and blur severity increases, and as we move from left to right, the non-linearity decreases, giving us a diverse enough set of blur kernels. Moving on to our approach, which is class-centric motion blur augmentation, we want to highlight that the training of the network remains exactly the same as for clean images. The only addition is a class-centric motion blur augmentation module whose output is fed into the neural network instead of the clean image for training. Here on, we refer to our approach as CCMBA in short. CCMBA takes as input a sharp image, its sharp segmentation map, and a set of motion blur kernels. Randomly with probability 0.5, it is decided whether the image is to be blurred or not. If not, the CCMBA module outputs the sharp image itself. If the image is to be blurred, randomly select a subset of classes present in the image. Then create a binary segmentation map with the foreground comprising the selected classes from the sharp ground truth segmentation map. Then sample a single blur kernel and generate the class-centric motion blurred image by alpha blending using the given equation. The output image from CCMBA is then given as input to the segmentation network during training. Note that when all classes in an image are selected for blurring, the synthesized image is the same as what you would get for a camera shake blur. This flexibility in choosing the number of classes to blur allows us to span the entire spectrum of motions that cause any kind of motion blur. So here are some samples of our augmented images. Note that while some of these synthetic motion blurred images may not make sense physically, overall it was found to help the network in learning better. We compare our results with a set of baselines. The first baseline is no retraining, where we want to check the pre-trained model's robustness to blur. Second is deblurring, to see if the deblurring as a pre-processing step helps alleviate the issue completely. Third is fine-tuning, to ensure that the model, if there is possibility for the model to learn the slight domain shift and maintain performance on the clean images as well. And the fourth is motion blur augmentation, to compare the benefits of space invariant blur augmentation with our class-centric space variant blur augmentation. We experiment with two network architectures, DeepLab v3 Plus and SegFormer, and two datasets, Pascal VOC and Cityscapes. And our augmentation improves the performance in the presence of blur while retaining the performance for clean images, as can be seen from the table here. Qualitatively, also our method produces more consistent results across clean and blurred images. Here are some more qualitative comparisons with the baselines, displaying the exact same trend. Our approach also outperforms the baselines and existing works on Cityscape C dataset. We also show results for real blur and sharp image pairs from deblurring datasets GoPro and REDS. When compared to the baselines, our approach gives more consistent results across sharp and blur images for complex real blur. In conclusion, an effective data augmentation scheme using ground truth segmentation maps and synthetic blur kernels was proposed for improving semantic segmentation robustness to motion blur. The class-centric nature of our augmentation enables it to perform well on real blur datasets like GoPro and REDS, especially for common classes like humans. Thank you. Please feel free to reach out in case of any doubts.